Okay, let's continue with our journey with the Arduino Student Kit. Now, I have three goals in making these videos. One, I want to keep things simple for an audience of young students. Second, I want to follow along with the Student Kit lessons so that you can continue and explore on your own. And third, I'm going to be using Tinkercad circuits quite often to demonstrate. I think it works very clearly to illustrate what I'm trying to talk about. I think it makes clear demonstrations. So let's jump right into our lesson 1 on electricity basics. So let's see, what we're going to start with is we're going to create a simple circuit to light up an LED light. So some of the parts we're going to need a power source. We'll use a battery. Now notice this is it says here a 9-volt battery. Notice that the two terminals are labeled plus and minus. You're going to have that on every battery. Even your car battery has it labeled a plus and a minus. We're going to be using some wires, which are conductors. Now you might also note that the rubber on the outside is an insulator, and that's put there so like our fingers don't touch the wire and that the wire doesn't touch other things. So this is both a conductor and an insulator, but for our purposes we're interested in that the wire is a conductor. Now there's one other component we're going to use. We're going to use some resistors. These are interesting because they're kind of like halfway between a conductor and a resistor, or a conductor and an insulator. They're designed to limit the flow of electricity. They resist the flow. It's like trying to run current of a river through a small hole to slow it down. Okay, so let's jump over here to Tinkercad. And what I've done, I've gone into the section called Circuits, and I'll say create a new circuit. So we're going to create the same circuit on Tinkercad, then we're going to create it in the real world. But I think it demonstrates real well what we're talking about in Tinkercad. So we got some over here with basic components. You notice these are a lot of these match up with what's in your student kit. There's resistors, LED, there's buttons, there's your Arduino board, and there's your breadboard. We're going to talk about those in this lesson. So let's start with our power supply. Here's our 9-volt battery, and it gives it a name. We'll name it battery number 1. We only have one in this circuit. And let's scroll to the top, and let's say we want to light up this LED. Let me move that a little closer and zoom a little bit so you can see that okay. Now let's just connect this up and see what happens. Now one thing you'll notice about these LEDs, let me go back and show you the real one. Notice on the real thing, one wire is longer than the other. That's going to be important. The one with the long wire is going to be called the sorry, I can't get it to focus very well. The anode, and the short one is called the cathode. No, don't worry about that name. But what you will have to worry about is that when you use these, you want the long wire to connect to the plus side of the battery. You know, I'm going to do it wrong first, so that you can see what's going to happen. So on this one, this remember is the anode. They're showing that a little dog leg. That's the long side. So let's come over here and create a wire. It doesn't matter what color wire for now. I'll leave it a green wire. So let's say what if we connect this to the negative side of the battery? That's the wrong way to do it. Now I'm going to click to deselect the wire, and then I'll click another wire from here to here. Now it didn't, and click again to deselect the wire. Now, kind of like it's really connected to the battery already, right? But to effectively turn the power on, I'm going to click the button here that says Start the Simulation. So when I click that button, well, nothing happens, right? These LEDs are called LED because they're light-emitting diodes. Now, a diode is a strange electrical thing that only lets electricity go in one direction. So when we hook it up backwards, nothing happens. So let's undo both of those wires and let's connect it up the other way. So I'll take a wire from here and I'm going to connect. Is that the way I had it? And then this time I'm going to connect this side. Okay, I'll come over here like this and go this way. Now if you want, you can, when the wire is selected, you can drag these things to kind of like if you wanted to straighten it out, just to make it look pretty. I can drag it to the I get a vertical and horizontal line, and then it makes the battery look like a nice bend. All right, what's going to happen now when I push Start Simulation? You might be surprised. Wow! So what it's showing me, not only that it's lit up, if I hover over it, it says, I don't know if you can read that, it's kind of small print. It says the current through the LED is 915 milliamps, while the absolute maximum is 20 milliamps. So 915 milliamps is almost 1,000 milliamps, which is almost 1 amp, which is actually a lot of power. You know, picture like a hair dryer is 15 amps, so this is 1/15 of that, but still a lot of power for this tiny little thing. So what this is showing me, we just burned up that LED. We'd have to get another one. So how are we going to fix that? Let's delete these wires and do it over again. What I'm going to do, I think you know the answer. I kind of mentioned it earlier. We're going to use a resistor to limit how much current we have. So I'm going to drag out a resistor here. Let's see, I wanted to put the resistor near the label here. So I'm going to make this resistor for now be 560 ohms. But go watch it. You got to watch what this thing says, because I've got it. By default it's on K ohm. Now that little omega Greek letter means ohms. So I'm going to pick ohms, not mega ohms. Not mega ohms, kilo ohms, or milli ohms. I want ohms. So it means 560 ohms. Now, if you notice when I did that, these little color bands changed. Now, when you look at these resistors, let me go back so I can show you. It's kind of hard to see, but they have these little color bands on them. It might help if I put a flashlight on to make it a little brighter. So this one is actually, I think it's like red, brown. But if I look in here, I do have some in my kit that are exactly like I made. These are 560. If I look at these have, I know it's hard to see, but they're green, blue, and then brown, and then the gold. I'll show you what that means here. We have a little thing that in our is part of one of the things you can build with the student kit is this little resistor wheel. So that resistor is 5. Let's see, where's the number 5, the number 6, and then the number 0, and then a gold. So what that says, so those color bands 5, 6, 0, and gold stand for 560 plus or minus 5%. That's how accurate it is. Now some other resistors have 5 color bands where they have a more precise number. But all the ones in my student kit have just these 4 bands, you know, the 3 numbers and a accuracy, if you can read that. So if you look at our resistor there, we've got a green, blue, brown, and a gold. And it tells me both, and that's one nice thing about Tinkercad is when I click on it, it tells me right away that it's 560, and I can see the colors, and that matches this, and it matches the real world. So it's a real nice way to kind of learn about this. Okay, so I've got a 560 ohm resistor. Now let's hook it up. Which way does it have to go? Well, this side of the long wire of the LED has to connect closest to the red side. But it doesn't really matter if I connected up the resistor first or put the resistor after. I could do this if I want. I could connect the resistor right on there, and I can take a wire. What if I take a red wire this time? It's kind of nice sometimes to use a red wire to indicate the plus side. So if I run this wire from here to here, and then I'll click to deselect. Now let me set the color to black for the ground side, and I'll run a wire from here straight to here. So does that look like the circuit has looked right? The long wire of the LED goes to the plus side, which is red. And if I hover over it, notice it tells me too that it's positive. I'm sorry that print is kind of small, but that's the positive terminal, and that's the negative terminal. So when I push start simulation, voila, it works. Now I personally find this a really good way to double check that I know what I'm doing before I go down to my actual Arduino and do the same thing. It kind of what I call a sanity check. Make sure I'm on the right wavelength, sort of, I understand what I'm doing before I connect it up. So cool. Now let me show you another way we make circuits. So that's just a simple way we made a circuit, right? Now notice a circuit means the electricity flows. Now this is confusing. Ben Franklin made a mistake here. He thought that current went from, and that's what we call it today, the current flows from the plus through the circuit and back to the negative. In actuality, it's the electrons are going from the negative to the plus. But people have stuck with this convention thinking of current going as the opposite way that the electrons actually go. So anyway, let's go back here and create a new circuit. I'll say create a blank page. And I'm going to do it like I'm going to be doing it on the Arduino breadboard to show you how that's going to work, and then we'll go do the actual thing. So let me scroll down here and bring out an Arduino component. Now what I like to do is kind of rotate it around so I can see it the way I want. So there's this button up here that says rotate. If I click that 3 times, it turns it up kind of the same way I've got it oriented here. Right? So we're comparing apples and apples. Now I want to bring out my little breadboard. And again, I'm going to rotate that 3 times. And I'm going to position it right beside the Arduino. I'll click to deselect. Pretty much just like I've got it in the real thing. The only difference is it doesn't have the plastic project board on the back, but that doesn't matter, right? Now what I'm going to do in this case, these tend to be the pins that we're going to turn on and off with our code. Some of these pins are analog pins. They're different, but over here there's a 5-volt pin and a ground pin. So what I'm going to do, I'm going to create a red wire, and I'm going to connect from this 5-volt pin. Let's just try to bring this out neatly, say, and bring this over here. And I'm going to connect to this pin here. Here, I'm going to just straighten that out. So what I've done, we'll talk more about this, but this whole row of the little holes on the breadboard is connected behind the board. There's a wire that connects them, or a piece of metal that connects them all. So that just makes like a rail that makes it convenient. I can connect things to any one of those pins to connect to the plus side. Now let's get a black wire, and let's go to this one. There's actually two of them here called ground. There's another one over here, but I'll just, because I'll connect this maybe to this one. I'll tend to connect to the one not right next to it, but the one, I'll skip one because it makes it easier to not short it out, not connect it to the, have it touched by mistake. So let's go down here and come over to here, and I'll just because I want to be neat, I'll straighten this out so that it lines up. So now what I've got the plus connected to this whole line of pins, and I've got the ground or negative to this whole line of pins. So now when I connect things on the board, I don't have to think about putting wires into these little pinholes all the time. I can use these little pinholes, but they're closer and easier to get. Okay, let's scroll back up to the top and get the same components that we used before. I'm going to use an LED, and I'll drag out a resistor. Now this time, because I'm using 5 volts instead of 9 volts, so the 9-volt battery is kind of a little stronger than what's coming out here, I'm going to use a different value resistor. I just know that a resistance of about 220 is what they recommend to use. And again, that's going to be ohms, not milliohms or kiloohms. And let's take that resistor. It doesn't really matter. What if I connect it here to, let me just, I'll put one end on, if I can get it lined up right, and what I call it's row 10, column C, or like C10, say. We got one end. It doesn't really matter as long as we connect it all up correctly. But I just want to do things the same way when we get to our actual board here. Now let's take our LED. Now the only choice for the LED is what color. We'll leave it red for now. If I want, I could make it a, an orange one, or I can make it a green one. Let's leave it a red one because I've got a red one out already. We'll make it the same. Now I'm going to turn this 90 degrees again. 1, 2, 3. And let me put that, say, right here, for example. Now notice, why did I do that? Well, this whole row is connected together. See how when I touch one, all the other ones turn green? Here, I'll blow it up so you can see it better. So this is effectively connected to that. That's how it's easy to connect things on the breadboard. I don't have to take like the ends of these wires and twist them together, or be kind of nasty. Okay, so now I want to connect, so that's connected to that. So which end do I want of this LED to go, this lead of the LED? Well, I want that to go to the negative side. So I'll use a black wire, and I can connect to any one of these, and I'll connect it from there to any one of these, and that connects that side of the LED to that negative power bar. And now, just to be neat, I'll use a red wire, and I want to connect this end, but I'm not going to put it in the same hole. You can't really put two wires in the same hole. So I'll put it in this pin 14A, and then over to there. Now, if everything looks wired up correctly, and I'll just double check this. Okay, so that's 220 ohms. Now notice the colors, it's red, red, brown. So if I have on my color wheel, if I have red, red, brown, and gold, it's 220 at plus or minus 5% ohms resistance. So that's a fun little thing that you can, it's in the resources area of the student kit. There's a link to it in the lesson. So let's just start the simulation and see, voila, it works right, okay? So let me stop it again. Now, just to make it clear, if you're a little confused, let me pick some green wires just to illustrate what's going on here. remember, everything across here is connected. So this is the same as if I had a wire from here to here, because there really is like a wire behind. And it's like as if there's a wire from here to here. And these are all connected, so it's like as if I have a wire from there to there. And because these are all connected behind, I really have like a wire from here to there in the back of the breadboard, and I have a wire from here to here. So I think now it should be easier to see how this connects as a circuit. So we start at 5 volts plus, we come around this red wire, come to this red section of holes up here. Oh, I didn't mean to connect. I meant for this wire to. Whoops. A little hard to pick them here. Not that it matters, but that was going to be down there. So I come up to this point. I turn, go to the resistor, and I go connect to the what's called the anode. That's the side of the LED that wants to connect to the plus terminal. I go through the LED and back to the negative and back down here and around, back to ground. So this is acting like my battery, like the plus and the minus terminal of the battery. Now, I start the simulation, it's going to give me the same thing. So I'll stop that simulation. And I don't need those green wires. Let me just undo until I delete all those green wires, and I'll start it again. As you can see, I didn't need those green wires. I was just putting those there to make a clearer picture of how it's connected behind the breadboard. So that's what the advantage of the breadboard. It makes it real easy to make connections. Now, let me just show you one. Just to make it clear again. Here's what the breadboard looks like. It's important to understand how this breadboard works. So here's what the breadboard looks like. We've got numbers going down, so the rows are numbered, and then the columns here, A, B, C, D, E, and F, G, H, I, J, whatever comes in the alphabet. I forget. So here's what it actually looks like behind the breadboard. So these are connected and these are connected, but there's no connection across here. Now that makes it handy because, for example, when we put a button, we might put a button across there, or we might put some component that connects across. So it gives us more places that are different. And notice we have a row of pluses on one side, a row of pluses on the other. You don't have to use those all the time. Sometimes we can connect things up directly to the pin we want, but it just makes a convenient place. If you're going to be using plus a lot and minus a lot, it makes it a convenient place on the breadboard to connect to. All right, so does that give you an idea? I hope it gives you a picture of what's behind the breadboard. And I think you can see then, because we have a whole row that are connected, if I put one thing in any pin there, another thing, any one of those 5 pins, it's like as if they're connected together. Okay, so we've kind of shown you how we do it with on Tinkercad. Let's do it on the real thing. Oops, I don't know what that was about. Bad gateway. Well, that doesn't matter. Let's go back to our real thing, and I'll try to remember exactly how we did it in Tinkercad. Now notice I don't have my power on yet. Remember, that was one of the safety things. We're going to make our circuit with the power not being on. Now I've got a couple wires here that are black and red with a pin on both ends. So I'll connect my red wire to where here it says 5 volts. You got to have good eyes to see these. I don't know if you can. Ah, boy, it's hard to get the camera to focus. There you go. It's upside down. See where it says 5 volts? So I put that to the 5 volts, and then I'm going to connect that. Really, I can connect to any one of those. I'm making a whole plus rail out of that. Then I'll come back over here and pick the ground one like I did before, where it says GND for ground. So I should turn it over so you can read it. So it's 5 volt on the red one and GND for the black one. So I can plug that one right next to it. These wires are longer than I need, so it's a little messy. That's why it's clear to see what's going on in Tinkercad, because you can make the wires just the right length. Okay, now I've got my LED. Now remember, let's carefully check which end is longer. So I'll put it in a couple of these holes here. And I got the longer wire on the bottom side. I'll put it like that. And then I need my resistor. I'm using a 220 ohm resistor. So that should be, it should be like this. It should be red, red, brown, and then gold. So it looks like red, red, brown, and gold. Those bands are so tiny, it's hard to see. Sometimes you even need to put a flashlight on it to see it. And I'm going to connect this like I did. I want to connect this in the same row as that anode of the LED. And you got to push these in until you can kind of feel that they're connected. Okay, if you can see those, see how I've got that connected to the same row 11. Now we're going to need a couple short wires. Remember I said, so this bottom end is the plus side, so I want to connect something to row 15 to this somewhere, something on that column of red pins. Now I'm going to need one more wire of some color. Let's see, here's a, it doesn't really matter what color it is. I happen to have an orange wire here. So I'm going to connect this one in the same row 10 as that LED. It doesn't matter which one I take, and that's going to go to, let's see, to one of these pins connected to the black pin. So let's kind of double check. See, it's a little harder to see on the real thing. I've got from 5 volt I go to the plus, and then from the plus I go to this row 15, and also in row 15, I got those kind of twisted around. I connect to the resistor. The resistor goes up here to row 10, and then the side of the LED is, the long side is also connected to row 10, and then the short side is connected up here in, I'm sorry, that was row 11. And now we're in row, so in row 10 is the short side. Then we got this orange wire, and it goes over to the set of ground pins. Okay, so that should be right. Let's plug it in and see what happens. Voila, look at that. So our light turns on exactly like we did in Tinkercad. So that's, I really like using Tinkercad because I even though that I know what I'm doing, it helps me check, you know, that I got it exactly right before I come over here. Now let me just show you something else. I want to notice that the little light is still blinking. I'm not really doing anything with the code in here, but that little code we put in on the last lesson that made it blink is still in there, right? So a funny thing that happens is pin 13 is connected to that light. So let me just show you something. What happens if let's disconnect our power because I'm going to change it. Let's leave everything the same except for the plus side here, this red wire. I'm going to move that over here to pin 13. So if you can see that, so as you see they're labeled on the side, they're labeled on both sides. So pin 13 now goes directly to the resistor, which goes to the LED, which goes to the orange, and the orange goes back to ground. So I'm using the same ground. Now just to be clear, this red wire isn't doing anything, so let me take it out of the way, okay? I could have left it on, but I just want to make it clearer. So my circuit now goes from pin 13 back to ground. Now the difference about pin 13, it's going to be blinking on and off. All right, so let's connect it back up and see what we get. And notice that's blinking exactly the same as the light on the built into the LED built-in light on the Arduino board. Cool? So some other things you can experiment with is what happens if you use a different value resistor. You know, you can use any one in your kit because all the resistors are higher value than this. You wouldn't want to put in a lower value because the lower the value, there's less resistance, and you might tend to burn out the LED. And it's not a big deal. The LEDs are not expensive anyway. But if you put a higher value resistor, what do you think will happen? You know, so those are some things that you can experiment with. And now would be a good time to explore some of the other things that I might not have covered in depth out of this lesson 1. On your website, there's in this lesson 1, electricity basics. There's the overview of what we're going to cover. Vocabulary, we talked a lot about some of this vocabulary, but not necessarily all of it. You might want to review it. There's a little bit about how electricity was discovered, some of the great inventors. Electricity and circuits, we kind of demonstrated some of this, and we built that circuit. We used our breadboard, shows how the breadboard works. We're going to cover more about measuring electricity in the next lesson. Here's some more information about resistors, both the series that have 4 bands and ones that have 5 bands. And here's where I got that resistor wheel. Let me open this in a new tab here. So this is that little thing that here's actually, you download it here. So this little, what I did is I printed mine on kind of like cardstock, and I cut it out. Now they have make little tabs. Instead, I used like a little metal brad that I could push through and bend. That worked well to put it in the center, so I could turn the wheels. So this card is the only one you need for the resistors that have 4 bands of color, which all mine were. If you have the 5-band resistors, you print out these 2 cards, and there's 1, 2, 3, 4, 5 little wheels you're going to assemble together. So I'll leave you with that. Those are some of the things that I think you can review. About batteries and other things. I think I've covered. The important part is how we made the little circuit. Because what I really want to emphasize is how we make circuits, and then how we integrated that with what's happening in the code inside that turns pins on and off. Because if you can make a pin turn a light on and off, eventually you can make it turn a motor on and off, or a relay which turns something that has higher power, or a fan. If it gets too hot, you can have it turn a fan on, things like that. So those are some other things we're going to be experimenting in next lesson. All right, that's it for this time. We'll see you in the next video.